Now this is a third video on topic related to Tom theory of machine, and we do here practical some with numerical. So friends, FO maximum FO equals to maximum amplitude of excitation by sinusoidal. A equals to amplitude mm, meter, and so many this unit. So amplitude A equals to F naught divided by K, spring stiffness in square root 1 minus omega n, omega by omega n का whole square to the totally whole square plus 2 zeta omega by omega n का whole square. So here friend, this formula used with a practical numerical. Our question is a single degree of freedom spring, degree of freedom of spring mass system with viscous damping. Viscous damping has a spring constant of 10 kilonewton per meter. The system is excited by a sinusoidal force of amplitude 100 Newton. If the damping ratio equals to 0.25, calculate the amplitude of steady state condition at resonant conditions. Okay, resonance condition is given here. So what at resonance condition, omega divided by omega n equals to 1. Here omega equals to omega n. Zeta given 0.25 here. FO given 100 Newton here, and K value is given here. Kilonewton, it will be converted in Newton meter. Okay. So friends, you calculated at resonant condition. This condition apply. So omega divided by omega n equals to 1, and 1 minus 1 equals to 0. So this value is cancelled out, and here it will be omega 1. So what formula you should here? So your formula will shortlisted by here. So F naught is given 100, K is given 10 multiplied 10 to the power 3 Newton per meter, divided by zeta square, root will open, so 2 zeta here, because this square and root will cancel out. So what amplitude equals to 100 divided by 10 multiply 3, 2 zeta value given 0.25. After calculating you got 0.02 meter. Amplitude equals to 0.02 meter, and if you want to convert mm, then 1000 multiply, it will be convert in mm. So 20 mm amplitudes are given in vibrating in damper vibrating. So this is your questions and answer you calculate like this, and I hope you enjoy this video. So thank you all of you.